This media was gratuitously produced by Clear Contributions Audio and Video. The intellectual property contained within belongs to Dr. Barbara Van Kyken. Clear Contributions. Let's have clarity.
All right, let's see what you got. Oh, and actually, I'm just remembering, so I better throw it out there right now while I still remember, because I forget things. Your options might be, and it's going to be the same course fee either way. You can choose to do just PDF and do your notes on your iPad, or you can do a combination of PDF and a hard copy paper workbook. How many of you would want to do the hard copy in addition to the PDF, so I know how many to print up? Okay. All right. Terrific. Thanks. Let's see how you did. All right, this doesn't have a functional group, so therefore you're giving the lowest possible number to a substituent. If you number this way, the first number you come to for a carbon with a substituent attached is 4. If you number this way, it's 3, so that's why you're going this way. I guess for extra practice, we can also name this. So your substituents are?
3
Fluoro. Okay, and then there's 8. And I know this is just going to be maddening to you. I'm not positive. I think the 2 vowels still stay there.
What?
I don't know for sure, but I think so. I can check that for you. And then you don't have more than one of any particular group. The numbers go just to the left of the location, or the substituent that you're describing location of. All right. This has a functional group, so that's the only thing you're looking at. So I threw the substituent in over here to try and confuse you, to see if you're just going for the lowest number possible. Also to just kind of get your blood pressure up, thinking, why, oh why is that a substituent when this is a functional group? But just to make sure you got those distinguished. All right, so then if we're naming this substituent is methoxy. Hexane, yep. And then all. See if there's more than one of anything. There isn't. And now just fill in the numbers that you've labeled. Good. All right. C, the functional group is the only thing that you're looking at. If you're numbering this way, the lowest number you can give it is a 2. This way it's a 3, so that's why you're going this direction. You have a bromo. Pentane, but wait, since it's a double bond or triple bond, the whole ane ending goes. It's not just a question of vowels being together, the whole ending's changed. And the number you give to the ene? 2. It's implied that it goes to the next higher number. And if you didn't name stuff, that's okay. I'm just giving you extra practice. It's just more for your tuition dollar. Okay, D doesn't have a functional group, so you're going to the first tiebreaker rule. Give the lowest number possible to a carbon directly attached to a substituent. If you're numbering this way, it's 3. If it's this way, it's 2, so that's why you're going this way. Okay, first write the components. Then because you have 2 methyl groups, put the di in front. And so if you had to do a tiebreaker where you're going with what appears first alphabetically, I mean in your list of components. And so this is a 2 and a 4. You have to tell where each one of the methyl groups is located.
Would you put the smaller number first on the larger number, or could you switch it up?
Smaller and then larger.
Does the di and the methyl count towards towards the alphabeticalizing of things, right?
The methyl does, the dye doesn't. And that's why I have that split out as step 3, so that after you've alphabetized everything, then you put the dye in the try so you don't get those confused. Good. Okay, the functional group is the only thing that you're looking at to try and decide the numbering system. Because it's a cyclic compound and you can start numbering anywhere that has to be 1 and 2, but it could be going either direction, so you have to number each direction and then pick the direction that will be the best. Either way that you go on this, the functional group has the same number, 1, so now you gotta go to the first tiebreaker rule, give the lowest number possible to a substituent. If you're numbering this way, the lowest number you can come up with is 1. If you're numbering the other direction, then the lowest number that you can give it is 2. So you want to pick this. Don't worry about what number this ends up with as a result. It doesn't matter. You're just looking for the lowest possible number for one of the substituents. Okay, so if you're going to name it, you have the methyl groups. I got that part. You get the rest. Okay? Parent hydrocarbon? It's a cyclopentane, and then you have to change the ending because you have an ene functional group. Like that. Okay, and then just third step, say that you have 2 methyl groups. Fourth step, assign the numbers. So this is a 1,5 dimethyl. And if you put a 1 here in front of the ene, I won't mark you wrong, but technically you don't need it because it's a functional group in a cyclic compound, so it has to be the number 1.
So an cyclic, what is it called?
A cyclic parent hydrocarbon?
You don't have to match up 1 and 5 going like backwards. They start here and go backwards. You just always have to make the parent or the functional group 1 and 2 and then 1 and 2.
That's right. Yeah. Or if you had a cyclic parent hydrocarbon and you have a different kind of functional group like an alcohol or an amine, it's just that has to be 1. And then you could number each direction from there. But that has to be number 1 because you're giving it the lowest number possible. Any other questions? Yeah. Oh, that's a question. Okay. All right. This one is mostly named. It's a myth that that's methyl, though. Okay, so this one doesn't have a functional group, so you go to the first tiebreaker rule, and you get the lowest number possible to a carbon directly attached to a substituent. 2. Oh, boo. So you go to the next tiebreaker rule. Give the lowest number to the next substituent in the line. 4. So then you go and give the lowest number to the next substituent in the line. Not there. Okay. So now you've run out of options. You have all the numbers are exactly the same. So you put the lower number to the thing that's first in your list of substituents here. Okay, and so that's why this one turns out to be 2 and 4. This is the correct numbering direction. All right, this one. Let's see, so you don't have a functional group, so go down the line and see what's the first number, 2. That didn't do really, so you gotta go to the second tiebreaker rule. What's next? A 3 versus a 4, so that's why you're gonna go with this numbering system here. 2, 3, 5 trimethylhexane, that's correct. And the last one. You don't have a functional group, so give the lowest number possible to a substituent. It doesn't matter that you have 2 4s as a result of giving this number 1. All you're looking for is the lowest number you can give something. If you're numbering this way, the lowest number that you can give to a carbon that's directly attached to a substituent is 2. If you number this way, you can give it the number 1, so that's why you're going to go that direction. Any other issues?
When writing out the name for that one, you put double forms.
Oh, thank you.
Oh.
All right, so you've got bromo, got 2 methyl groups. Step 4, assign the numbers. 1 bromo, 4 dimethyl. Sure. There's no functional group, so the first tiebreaker rule is give the lowest number you can to a carbon of the parent hydrocarbon chain that's directly attached to a substituent. So if you're going this way, the carbon is directly attached to bromine on carbon 1. This direction, carbon is attached to a substituent on carbon 2. So that's all you're looking at. So the lowest number, not averages or aggregates or anything like that, just the lowest number.
Because it's a dimethyl, do you have to put the 2 4s, or can you just put the 1?
Good question. You always have to assign a number to each item. If you only put the 1 4, then it would be ambiguous because it would be unclear whether you forgot to write one of the numbers or they're both the 4. So you just, for clarity, you just put a number for everything, even if it's the same number. Good question. All right, other than, why are you doing this to me? Why, oh why, oh why? I guess it's been more than 15 minutes. There we go. Okay. Other than the few exceptions for when you don't have to include a number, which I just want to hold off until you are really solid on the rest of this, other than that, you know all the process so far for naming an organic molecule. Just go through those 4 steps in order. We can go through and kind of summarize it here on page 17 for you if you'd like, but then I wanted to start working through some of the problems as kind of a guided practice, although I think you're really getting this really well, and then just give you some homework for it. So just putting it in your own words, what's the first step you do? Identify. Identify the compounds. Identify, and you want to put it in the order of functional group, parent hydrocarbon, substituent, because everything is based off of the functional group. You can't tell what the parent hydrocarbon is until you identify the functional group, since the parent hydrocarbon has to be directly attached to the functional group. Okay. Do you remember that there might be cases where there are 2 different ways where you can trace through the molecule? They have the same number of carbons, they're attached to the functional group, so they meet that criteria and everything, but they give you different answers for what the substituents are. They're not equivalent directions of tracing through. Do you remember what the tiebreaker rule is for that? How you decide which of those 2 ways you go through? That's the parent hydrocarbon tiebreaker. Yeah, you go through the more branched. Remember that? It's kind of, let's see if I can come up with something on the fly here for you. So you could go through this way, or you could go through this way, and you're coming up with the same number of carbons either way, but they're not equivalent because this substituent that you'd have here if you went through this direction, that substituent is not the same as if you went through this way and you've got a substituent here and a substituent here. So because this has branching in it, you go through this direction that I marked in green. It's simpler to name a methyl group and an ethyl group than it is to name this component, I think is the reason why. But anyway, that's the tiebreaker. All right, step 2. Yeah, write the components or write the names down. And that you're going to do in the order of the opposite of how you identified everything. So you write the substituent first, then the parent hydrocarbon, then the functional group ending.
Oh, the second step was writing down the name.
Write the components of the name. Yeah. Three is?
Two of the substituents or two of the
Functional group.
function diagram. Yeah.
Yep, so say if you have more than one of any particular substituent or functional group, like put dimethyl or trimethyl or diol, whatever applies.
Wait. Step 2, write the components of the name. We start with
The substituent, and then the parent hydrocarbon, and then the functional group. So it's exactly the opposite order that you identified them in. It has to be that way just because the process for the substituent parent hydrocarbon functional group is already established if you're writing left to right.
okay.
But you need to know first where the functional group is located to identify the parent hydrocarbon. So it just has to be opposite. All right, and then 4? Number, and you go by the numbering direction that gives you
The lowest possible number of components attached to the function.
to the functional group. You have to have the lowest number of the functional group. So only look at that. Don't care about anything else. Only go to the tiebreaker rules if there is no functional group, or you get the same number in each direction for the carbon directly attached to the functional group. Okay, the first tiebreaker rule is
Most number for the substituent.
for the substituent. Lowest number for the substituent. And if that's the same number, next substituent. And just keep going until you run out of substituents.
And if it's the same all the way across, then that means that the name wouldn't be different, so it doesn't really matter.
Right, if you have the exact same substituents and the numbers are an exact match, then it doesn't matter which way you go because you can come up with the same name. But if the substituents are different, then that's when you have to do the alphabetical. And then, yep, the last step is the alphabetical. Lowest number goes to alphabetical. All right, and the reason I put them in this order, step 1 has to be first because you have to know where the functional group is before you can do any of the rest of it. You can't really number until you know where the functional group is. You can't assign the name until you know what the components are. And the reason why I put step 2 before step 3 is because you don't use di or tri or any of those tetra, penta for alphabetizing. So depending on how well you do tonight with your homework, then we'll either work this some more tomorrow, or we'll go on to chapter 2. I feel like you're really kind of getting this down okay. So we'll see how one more go through with practice helps. In all of these chapters that I'm giving you, I've got kind of a guided practice for you for different problems and like a framework for you to work within with the rules. And then I have the problems at the end of the chapter where you just work without guidance and just get your confidence up. But we can work through a few of these guided practice today just to make sure that you're okay. Do you have any questions though before we get started on any of these steps that where you're kind of fuzzy about something?
Yeah, so if there's 2 substituents, but let's say, so like on this one over here, would we be able, like, if we didn't have to take in the that other rule about having which one alphabetically first. Never mind, I just answered my own question. Alright, sounds good.
Anytime I can help. And this reminds me that the chemistry tutor is going to be in Durham Tuesday and Thursday night, 6 to 8. I don't know what room yet. Okay. Let's see. Mm-hmm.
You said in the rule that if there's more than one substituent or functional group,
Mm-hmm.
have we done one with the two functional groups yet?
No, I don't think we have. Do you want me to show you an example?
Yes.
All right. I need to come up with some more examples where I'm turning corners. I'm making too many apparent hydrocarbons linear, so you're gonna get lazy, but oh well.
You could turn it on this one and not change it.
That's true. I could go like this and then put that as a substituent. All right, so we've got an ethyl group and a methyl group. And I think a non-name 3, 4, 5, 6, 7, 8, 9, yeah. And an alcohol, so an OL ending. Then step 3, if you have more than one of anything, put di or tri in front of it, so that becomes a diol. Because it has a D there, if you're a purist, you don't have to drop the E. But if that just makes you angry at this point, just don't worry about it. It's little.
What if it was like a double bond inside of there, or does that just not exist?
You can, and that's what we're going to be doing next semester. If you have multiple functional groups that are different kinds of functional groups, then sometimes you have to prioritize, and then you change the functional group name to something that goes with the substituent section. It'll be a whole new issue. Yeah, so for right now, we're just going to do if you have multiple copies of the same functional group. That's what I love about you guys, though. You're always looking for a challenge. Okay. Now we're looking at this and this. 2 is lower than 4. Oops, 7. See, that's the beauty of it. It's just the same process over and over and over, so you can just name anything. Just apply the rules. You got them. That's why I love organic chemistry. It's a lot like math class that way. Once you learn the process, you got it for anything you see.
So why 7 ethyl?
Why what?
7 ethyl?
This is attached Here.
Oh, okay, I didn't see
Yeah,
that.
I know. I actually wrote 6 first because I didn't
Yeah.
see quite.
Thank you.
It got cluttered with the 7 there. Good. All right. Since I feel pretty comfortable with how you're doing, and we have a limited amount of time, let's be selective in what kind of problem you want to practice with. We have this problem where, and just stop me when you're like, I like that one. This problem where it's a little bit trickier to find the parent hydrocarbon. The next one's where you're naming an amine. I'm getting for the amine. Is the amine an issue? I have an amine and I have a alkene.
Ooh, yeah, alkene.
And I have an ether. All right, I'm getting kind of feedback for all of those special ones, so we'll do 2 first. So what I've got going on here is for you to kind of work step by step through it. I'll let you try 2, and then we'll go through it. You can ask me any questions you got about anything you're iffy. Yep.
So when you have
Ethyl?
an ethyl group, but it has the double bond between it, you have to label where the double bond is.
You do not.
When you have a what?
An ethyl group, just a 2-carbon unit. If you only have 2 carbons, then the double bond has to be between those 2 carbons, so you don't have to put a number for that. And that is one of the second of the 5 cases of when you don't have to put a number.
What is the ending for nitrogen?
Amine?
Amine.
It doesn't matter whether the nitrogen only has hydrogens attached to it besides the carbon, or if it has all carbon groups or something in between. It's always an amine.
Whenever you have the propane, would you switch it to an O because it's attached to the carbon?
I'm sorry?
Whenever you have a propane, would you switch it to an O at the end because you're attaching it to a carbon?
No, if it's a substituent, then it's a YL ending for anything where you have carbons. Just like you had methyl and ethyl, so it becomes propyl.
That's really funny actually, because I didn't do it for the propane, but I did it for the ethyl.
It's probably just a difference that you haven't really worked a lot with propane yet, and so you don't have that in your head quite as easily.
And also for that, because the ethyl is the diethyl attached to the nitrogen, would I put that out front and then have propane by hexane, propane by the hexane?
No, you're only going by alphabetical order for what
Oh,
goes
you go by
first.
alphabetical order on these ones.
Uh-huh.
Oh,
Uh-huh.
shoot. I didn't know.
Why the left side in the substitution, the 3 ones were green? Because I did the bottom ones and on this side, but not the very top on the left.
You did which one? Let me see.
I did this correctly.
Uh-huh.
I took all this as a parent and I didn't I did this green.
Okay. Good question. So are you... Oh yeah, that is kind of showing up. The green could be darker though, huh? I'll try to use some darker green next time. Any issues with finding the parent hydrocarbon? Okay, so now the nitrogen, because that's the functional group, you have to have the parent hydrocarbon directly attached to it. So that's why you have to come down to that carbon. And so then when you're tracing up, you can't go both directions. You just have to keep going one continuous line. So when you come to the carbon right above it, you could go to the left and pick up 3 or go to the right and pick up 4. That's why I went with the 4, yeah. All right, any issues with coming up with the components of the name? Okay, step 3, just to save a little bit of time, that's a diethyl. And then step 4, if you're numbering the parent hydrocarbon, you have to give the lowest number possible to the carbon directly attached to the functional group. You could number in both directions if you really wanted to, but it's kind of plain to see that that's the correct numbering direction. So let's see. Both of the ethyl groups are attached to nitrogen, and so you have to give a location for each one of them. So that means 2 N's here. And then the propyl group is attached to carbon 2, the parent hydrocarbon, and the amine is attached to carbon 1. And for reasons I can't quite figure out, it's really common for students to forget to put the number for the amine ending. So all I can tell you is maybe if you've got a space there or something, it might help you. And if you're ever confused about whether you should write a number or not, write the number. I'd rather have you be redundant than not give the correct
With that
information.
nitrogen, you have to put the double in for it because it's the diethyl.
Right. You have to say where each ethyl group is located, even if it's the same location. All right, so I was getting a lot of faces with the alkene, which is number 5 on page 22. Let's see if that creates any questions. YL. Let your bitterness work for you. So this is half of the test. See, you two can do organic chemistry. Not bad. That create any questions?
Yeah, just to make sure. I mean, it looks like we did it right, but
But
the it doesn't have to have the 1 for the functional group. That's
it
what I
has a
was
3 for the functional group.
right. But
Oh,
I just
right, right.
For functional group, I just have the lowest number.
Right, so I think what you're getting confused is partly that you're thinking about the lowest number, but if you have a chain like that,
Yeah.
then it is where it is. You know,
It
so
is,
it doesn't
okay.
have to have the number 1. What you're probably kind of mixing together is if you have a cyclic compound and you can start numbering anywhere, then it has to have the number 1. But in a
That's
chain,
okay.
it doesn't have to.
Okay. But like on the one to form the nitrogen, 1 had to be the carbon that was attached to the nitrogen.
It just ended up being that that was attached to the end carbon of the parent hydrocarbon, but it doesn't have to be.
Oh. Okay.
Yeah? All right, very quickly we'll do the ether. And while you're working, which is on the next page, while you're working, I'll just tell you, if we get going on chapter 2 tomorrow, it'll be helpful if you bring your molecular model kits. Okay? And remind me, I'll tell you about RAM in a minute, too.
Yeah, that's like your first one. So hardly
What is it?
Butane.
They crossed it out. If I can cross it out, that would be good. I'm just looking at the oxygen.
So,
Yeah.
This oxygen is attached to the parent hydrocarbon.
Mm-hmm.
Would I change this to OXY?
No, because this is a substituent and you already have the OXY in that substituent name.
Just making sure.
Yep.
dimethyl sounds like it comes first, but it's only That's the thing. It goes to the second one, right? Wait. This one here?
But still, the exact same thing. That means what you have to go to.
Oh, I got that totally wrong.
What questions do you have?
I completely forgot we could take turns. Corners.
So if they're both at two, so then you go to
Oh
that.
my god, I just did it. I completely forgot.
That's right, because it's tied all the rest of the way. Let your bitterness work for you.
Oh, yeah.
It's not even butane anymore. Why did you tell me butane?
Did you ask? You said what has 4 carbons. I'm answering your question.
You should have been like, it's butane, but that's wrong. Oh, yeah, take a blue.
Cross out the O, get rid of that thing.
Sorry?
Buena Vista.
Well, yeah, that's for this semester, but that's true. Buena Vista, too. It will be in March. The RAM meeting was postponed, and I'm kind of thinking that since this Lee County is like the 22nd, 23rd of this month or something like that, that's coming up really soon. It's 2 weekends from this one coming up. So I just wanted to get you the information. If you want to go to RAM trips, go to ramusa.org, register as a volunteer, and then sign up for the clinics that you would like to go to. The 3 that we are officially going to are Lee County, Charleston, and Emporia, or something like that. These are Virginia clinics, and then Charleston, West Virginia. There's also a clinic in Grundy, and that's a really fun one because they let you work in the blood lab and they teach you how to draw blood and everything. But I've been told that that's homecoming weekend, and so probably most students don't want to go. But I'm throwing that out there in case you did want to go anyway or whatever. So anyway, go register, and that way you've got a spot. So once they have the meeting for you, I think it's next Wednesday, then you're not locked out of the RAM system, because they have too many volunteers. So anyway, there you go. All right. Your homework. How could I forget to give you homework? I don't know. Since you seem to be getting this and it goes pretty fast for you, pages 37, 38, and 39. We'll just call it like that. 37, 38, 39. Those are all just naming, so you got to combine everything together. All right.